Okay, so we had a homework assignment due today. Any questions about the first assignment? Yes.
On the stack frame, like
So is it just before the return? If it's just before the return, then yes, the values should be the values that the void function changed.
okay.
Yeah. Actually, today's topic is this chapter on C, so we'll probably be doing some stuff in the lecture that will help with the exercises that are due today, so anyway. Any others? Yeah. Oh, that's a good question, and the answer is yes. Okay, so I gave you all a 2-digit number for handing in the homeworks, and so when you hand in the Towers of Hanoi problem, which I think was supposed to be named capital P-R-O-B. Oh, yeah, and then when I have that little phrase on the assignments that says according to the specifications, that means pre-pinned your 2-digit number. So, other places, other schools might be using these videos in the book and they might have a different system, so anyway. Yeah, but so the answer is yes for Pepperdine students, yeah. Okay, any more? All right, okay, here we go. What is it that we have to memorize? What the C memory model. What's the first part of the C memory model?
Global variables at a fixed location.
Global variables are stored at a fixed location in memory. And how can you tell if a variable is global or not? If it's outside a function. If it's outside of a function, it's global. All right, what was the second one?
Parameters are...
Parameters, what and what? Local variables and parameters are where? On the runtime stack. So local variables and parameters are stored on the runtime stack. And what was the third? Dynamically allocated variables, yes? Stored on the heap. And actually, somebody asked after the lecture last time, where is the heap? Because we were saying that the global variables are at a fixed location in main memory, and then the question during the lecture was, where is the runtime stack? And the answer is it is also in main memory, but the answer is also the same for the third kind of variable. The heap is also in main memory. Are you with me? So it's in different parts of the main memory. And what we're going to see is that all computer systems have what is called a memory map that specifies exactly where in main memory those things are. And we will have a memory map in our computer system that will actually literally show in that main memory part where they are. So they exist in main memory during execution of the program. Okay, are we good? All right, now, here's the next thing we have to memorize. What happens in a function call? Now, we're talking about a non-void function. So now what was the first one? What about the return value? You push storage for. Okay, so remember, this first one is you push storage for the return value. Now what was the second one? You push the parameters. And this one is not the storage for the parameters. This is you push the actual parameters. So those parameters have values and they get pushed. Now what was the third one?
Push the storage for the local.
It was not storage for the locals. You're missing one.
Oh, the return address.
The return address, okay? So you push the return address. And now why do you need to push the return address? Because when you call a function, then the function executes, and what happens at the end of the execution of the function? What does it do? It returns. So you can have the function called several different times, and each time it returns, it's returning to a different place. It's returning from whence it got called. So what does the system have to do? What does the computer system have to do? It has to give the function the return address so that when it completes, it'll know where to go back to. Do you see? That has to be, there's got to be a way for the system to remember that. Okay? So you push the return, and now what was the last one?
And then push the variables.
Yeah, but now this one is storage for the locals. So notice that there's storage for the return value, storage for the locals, but we're actually pushing the actual parameters and we're actually pushing the return address. Is everybody good? Okay. And then in function return, it's just the opposite. And then we looked last time at this figure 2.4, and we saw that they are global variables, so they're declared in a fixed location in memory, and we saw this figure 2.5. And the way we're going to draw this is the fixed location is just out there, you know, in part A of figure 2.5, the CH and the J are there at a fixed location in memory, but then the runtime stack is the stack is going to, when you push items on the stack is going to go up. We'll draw it as going up, and we'll draw this little ground, you know, on part B of figure 2.5, this little, it's like the stack is a stack of blocks, and you put the blocks on and take them off. Yeah? Are we good? Okay, so what we want to do today is just, now we're going to go through kind of pretty rapidly through some of this stuff, because I assume we all know how to program. Actually, let me just make one more comment about figure 2.4. Now in C, what happens is, you'll notice that the scanf has ampersand CH and ampersand J. So in C, the ampersand is the address operator, okay? And so what, when you see this ampersand CH, that's the address of CH, and that ampersand J, that's the address of J. Because what happens is when you input a value into a variable, it has to be stored at a location in memory, and that ampersand is giving the program the address of where to store the value in main memory. Does everybody see that? Okay, so that's what the ampersand is. So anytime you do a scanf, you use ampersand. All right? And then, any more questions about figure 2.4? About how you see how scanf and printf works, how you have these percent things with the values and stuff like that. So it's a little bit different from C or Java. All right, and here in figure 2.6, what kind of variables are exam1 and exam2 and score? They are integers, that's their type, but are they local or global? They are local because they are inside main. What about bonus? Is bonus a variable, yes or no?
No.
Correct, it is not. So is it stored at a fixed location in memory, yes or no?
Yes.
Yeah, it's not a global variable, so is it stored at a fixed location in memory? No, because it's not a global variable.
But it's also not local.
But it's also not a local variable, so we'll see. The mystery will be resolved in the future. It will have to remain a mystery for now.
The constant, that's why?
Const, yes, const. Yeah. Are you with me? Okay. And then we have scanf, and then etc. All right. So, so let's count how many items are on the runtime stack. So, in the runtime stack, who calls main? The operating system. So what happens when you allocate storage? What happens when you call a function? Storage. So that's one, the ret val. What's the next one? Does main have any parameters? No. So what's the next one? Return S, so that's 2. And then storage for the locals. Now how many locals? And so in what order? Exam 1, no, not 4. Only const is not a local variable.
I said score.
Yeah. Okay, but anyway. Okay, so what? So then, and then exam 1, exam 2, and then score. Right? So does everybody see then that when this program executes, oh, and here in figure 2.7 there's, you know, all this integer division and mod stuff. Right? So you see here in figure 2.8, A, there's 1, 2, 3, 4, 5. Ret val, return address, exam 1, exam 2, and score. Now do you see the order that they're in? They get pushed onto the stack in the same order that they appear in the program. Is everybody clear on that? And then after the input statement executes, there's those values. And so are score in exam 1 and exam 2 at a fixed location in memory, yes or no? No, they are on the runtime stack. Is everybody good? And we see these figure 2.9 equal, less than, we know that stuff. Figure 2.10, I think These next few programs are self-explanatory. Scanf, num. We have a if-else, so everybody knows how if-else works. And then here's ampersand, ampersand for and in figure 2.11. We all good with this, right? And here's the switch statement. You remember how the switch statement works? By the way, the reason we're reviewing all of these control aspects of C is because the goal of this course is to understand how the translation process works. We are going to be translating all these into assembly language. Every one of these, all of these, we'll know how to translate. We'll see how the compiler translates. So you remember how the switch statement works with case 0, case 1, case 2, case 3? Okay, so there's figure 2.12. We'll see how that works. In figure 2.13, we have a while loop. And where is the test of a while loop? It says while letter is not equal to the asterisk character. So where is the test for the while loop? Is it at the top of the loop or is it at the bottom? It's at the top. So does everybody see how that's a while loop? There's the input. What it does is anytime it finds a space, it puts a new line. You see how that logic works? Okay, so we're not going to dwell on that. Now, in figure 2.14 is a do loop. Now, how does a do loop work? It says do blah, 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 while. So now what's the difference? The test for a do loop is at the what? Is at the bottom. So we'll see, when in assembly language, we'll translate that accordingly. Is everybody good? Okay. Figure 2.15 is what do we have? We have a for loop. Now, what are the three parts of a for loop? For, and then we have j gets 0, so the initialize, that's the initialization, and then the test, and then what happens each time through. So, and on this for j gets 0, j less than 4, j plus plus, what happens is first j is initialized to 0, then it's tested j less than 4, and it is less than 4. Then the scanf happens, and then what happens? The j plus plus, and then it goes back to the test. So all of that has to happen. All of that mechanism is all kind of invisible or is kind of built into the for statement, but when we translate it to assembly language, we'll have to do all those parts of it. So everybody, you see how that works? Okay, so that's figure 2.15. Now, here's the thing. Main in C is always of type int, so it's not void. So what's the difference between a void function and a non-void function? Because what did we learn, the four things that happen with when you're calling a non-void function? First thing was what? Push storage for the return value. But in a void function, there what? There is no return. So it's just the same as with a non-void function, only you omit that first step. Are you with me? So if it's a void function, all you do is you push the actual parameters, then you push the return address, then you push storage for the local variables. So it's the same as only you do 3 things instead of 4 things. So everybody see how that works. Okay, so the runtime stack doesn't have that retval part to it. And then when you deallocate the process for a void function, again, it's just like deallocating for a non-void function, except you don't pop the return address, the return value. Yeah?
If you're not going to return anything, why would you need the return address for a void function?
That is a good question. Because when you call a non-void function, at the end of the call, it still has to return, right? It just doesn't, it has to actually keep executing from where it got called, even though it doesn't return a value. So yeah. So those are two separate issues, right? Okay, so now here in figure 2.16, let's dwell on this a little bit, in a little bit more detail. First of all, let's take a look. Num points, value, and j, are they local or global? Global. Therefore, they are stored where? Fixed location in memory. Okay, are we good? And furthermore, we have a void print bar with an with a formal parameter A. Are we good? And then we have an int, our usual int main. Okay? So now, and so what the, here, before we analyze it, let's take a look in the next slide. So what this does is this is a little C program that prints out a little bar chart. And you see the input there has 12, and then 3, 13, 17, 34. So that 12 is how many numbers follow. Are you with me? So the 12 is how many bars there are in the bar chart. And then the 3, notice that the 3 produces 3 asterisks, and the 13 produces a row of 13 asterisks, and then the 17 produces a row of 17 asterisks, and so on. All right? So a little bar chart printing program. Does everybody see what that does? So let's go back. So what happens is in the main program, we input the number of points, and then we have a for loop. For j gets 1, j less than or equal to num points, j plus plus. And each time we go through that loop, we read that next value, and then we call print bar, and we are passing value as a parameter. All right, so now this is our first example of having an actual parameter. Now let's think, how many cells are in the stack frame for main? So, does main have any local variables? Yes or no? It does not. So what are the items on the stack for the main program? It's going to be the return value first, and then the what? The return address, and that's going to be RA0, which is going to be the address of who calls main? The operating system. So that'll be the return address in the operating system. Now I've indicated here in this program, you see that RA1 in main? That is just a comment that I put in there to show that that's the return address, because after you call print bar, you got to go back, you come back to that RA1. So that's just a little high-level comment for us to be able to see what's inside the return address cell of the runtime stack. Yeah.
So the return address is like after the line?
That is a really good question. So the question is, the return address is after the 1. And that's a really good question. The answer is now think about this. In a void function, it is the 1 after. But in a non-void function, like if it was returning a value and you were like adding that value to another one, then it would go back to that expression in the same statement and return that value and then do the addition and then go on. So do you see how that's a really important detail.
It knows. How does it know?
The question is, how does it know? And we will see exactly, see all these questions that are coming up? We're going to answer all these questions when we learn how it does the translation. So stay tuned.
Professor, so a stack frame is just like a return value, and then until the next return, like...
Yeah, that's a good question. The question is, what is the stack frame? Let's hold that thought. Right. I'll show. We'll see right now, actually. Okay. Is everybody clear on this stuff? Yeah. Question.
What does scanf do exactly?
Scanf is an input statement. So scanf is what gets. Look, scanf is what in the next slide. It's getting the 12. So it gets it from the input. All right? It's an input statement. Scanf and printf is the output statement. Are we good? Actually, what's going to happen is we're going to do after we do a few examples with the stack frame for the main program, after a while, it's the same thing. We're just going to omit them. I mean, we're going to omit that after a while. You'll see after a while, I just got tired of always doing the main stack frame, so we'll just, I don't know. Yeah, just whatever floats your boat. Anyway, so is everybody clear on this? All right, so but for now, let's do consider the stack for main. So main is going to, well here. So here in figure 2.17, we see that num points value in J are global, so they are stored at a fixed location in memory, and then the main program has ret val and return address, right? Are we good? And then what happens in the program is we do scanf. Actually, here, this is an answer to your question. Look in part B of the figure. Scanf, that 12 goes from the input stream to num points. You with me? Okay. And then what happens is we get into the for statement, and it's for j gets 1. So there, the j gets 1 in part C of the figure. Are you with me? Is everybody good? And then now we're in the loop where we do the scanf, and we get that first value, which is a 3. That was the first data value. We're going to print 3 asterisks, right? But now let's go back to the program. Well, but now do you remember in the program? Now what do we do? We call. Yeah, it's a call. Okay, so now do you see in figure 2.16? Now we've done the scanf for that 3, and we're now saying print bar value. All right, we're saying print bar value. So here we go. When we do print bar value, now what gets allocated? Now this is going to be the answer to your question. What is a stack frame? We're doing print bar value. So now what gets pushed onto the runtime? What happens when you call a void function? First thing is what? Well, yeah. If it's void, if it's void, there's no storage for the return value. So what's the first one? What was it? Push the actual parameters. So now, do you see so the actual parameter is n. Now notice that we label the runtime stack with the formal parameter name. Is everybody clear on that? That n is the formal, but the value that gets pushed, that 3, do you see that the 3 is on that cell in part E of the figure 2.17? Is everybody clear on that? And then what was the next thing that gets pushed? Return address. So you see so there's the ret address, and we have labeled it RA1. Is everybody good? Okay. And then now are there local variables? Were there local variables in there? I think there wasn't there?
Yeah, okay.
It was K, right? Okay. Was there more than one?
No, just K.
Just K. Okay, so it's K. All right. Now, that group of cells that was allocated in one function call together makes up what is called the stack frame. There's two names. One name is stack frame, but there's another common name you should be aware of. It's called an activation record. So those are synonymous. A stack frame or an activation record. Okay? And then what happens is, and so on. Okay, so then it does the computation, and then it pops them off, and then it calls it again, it goes up, it does the computation for the next bar, and calls them off, and does everybody see how that works? Yeah, now that's a good question. We're not ever going to do that. So notice, let me go back and explain that. Notice that in the function, it says int k, in the function print bar in figure 2.16, it says int k, and then it says for k gets 1. The common coding convention is for int k gets 1. Now the difference is, if you say for int k gets 1, what happens is that k gets allocated on the runtime stack only during that for statement, and after the for statement it gets popped off. So it gets on the runtime stack, but it's not when the function is called. Okay. So it's just its scope is only in the first statement, but I don't want to we're not ever going to, we're going to simplify, we're not going to use good coding style here, and we're going to simplify it by not
All right, so
doing
that's
that little
fine.
complication.
I was gonna worry, so that's why we're declaring.
Yeah, our four variables, yeah, yeah. That's not good code, don't take that as good coding style. But it just makes it easier for us to visualize the runtime stack
Okay.
that way, yeah.
That occurs after the for loop.
Yes, that is the big difference, is if you declare it outside the for loop, you can access it outside the for loop. And if you don't, you can't. If you declare it inside the for loop, you can't access it because it goes onto the runtime stack only during the for loop, and after the for loop it goes off. But see then, and that's the way, that's true in general in C. That's true in G. The scope is the compound statement, which is the brace. See, so anyway. All right, that was a good question actually. And this is, we're going to, you know, here's the thing, you guys. It's, in a real computer system, is so complicated that in order to get the ideas behind it, we're going to do a lot of simplifications, and that is one of them. So, you know, yeah, that's the idea. All right, so figure 2.18 is another example of a function call, and it's a factorial. I don't think there's too much different here from what we saw previously. Oh, except for the fact that here fact is it void or non-void? It's non-void. So now what's the stack frame going to look like? It'll have a return value. So here it is. So here it is. Oh, and num. Let's go back and see what num is. Num local or global? Global. It's global. See it up? It's outside. Okay. So there's num. You see how we illustrate that? It's at a fixed location in memory. It's not on the runtime stack. Does everybody see that? So there's the stack frame for the main program. And then we scan F into num, so num gets 3. And now we call, so now what's the first thing that happens? Push what? Now notice that it's pushed, it's not quite push the return value, it's pushed what? Notice that when you push storage for the return value, you don't know what's in that cell yet. Do you see what I mean? So we're pushing storage for it, so there's just some garbage value in there, we don't know what it is. Okay, and then what happens next? Yeah, now which one is it? Is it parameters or return address? Or is it local variables? It's parameter, but now we push the parameter. Okay, so now you see n is the parameter and its value is pushed. It's not just storage for n, it is. Does everybody see that? So that's, and now what's the next one?
And that's the return address.
Now it's the return address. And then what was the next one?
Local variable.
And does this have local variables? A local variable? I think it does, doesn't it? Okay, so F and J. Does everybody see how that works? So here again, there's your stack frame. You should be able to count how many items are in the stack frame, know exactly where they are in the stack frame. That's going to be important when we get to the translation process. Okay? All right. And then here, when it says F gets 1, then that cell F gets 1, and so on. Okay, now, you guys remember when you did your C++, we have this concept called call by reference versus call by value. Okay? You remember that?
Call by reference is the original.
Yes. So I assume that you guys have all had this before, okay, so this isn't new. But what happens is, in call by value, the formal parameter gets the value of the actual parameter. And that's what these examples that we've done so far, all of those parameters have been called by value. Okay, in call by reference, the formal parameter gets a reference to the actual parameter. And so the result of that is that if the formal parameter changes, the actual parameter does change. All right, now, and I assume you all know how that works. But now here's the thing about C that you might not know if you haven't programmed in C before. Technically, C does not have call by reference. In C, all parameters are called by value. But there has to be a way to achieve the same effect. So how do you suppose it is that we achieve the same effect? What we pass is the what of the parameter, the address of the parameter, and then the actual parameter is a what? A pointer, because a pointer is an address. Okay? You guys have all dealt with pointers, right? Okay, so that's how it's done in C. All right, and so this is going to be an example to show that. So in figure 2.20 we have this main program, and this main program, what does it say? Oh, actually here, before we look at it, let's take a look at the next figure at the input-output. It says, what the program does is it says enter an integer. The user presses 6. Then it says enter an integer. The person presses 2. It says order the R 2, 6. And of course, if the user had put 2, 6, had put 2 first, and then 6, it still would have said what? Order the R 2, 6. Are you with me? So what this does is it puts 2 things in order. So now how does it do it? Now check this out. The main program calls what function? Look there in the main program. What does the main program, after it enters the first one, enters the second one, it calls what function? Order. And what is it giving order? It's not giving order A, it's giving the address of A. A is a global variable and B is a global variable, right? So it's giving it's passing the address. And now in void order, we see the formal parameter has, what is the type of X?
Pointer.
To a what?
Integer.
To an integer. So X is a pointer to an integer. So do you see that X is an address and ampersand A is also an address? So they are compatible. Is everybody clear on this? We actually did this, and we actually demoed this in data structures last semester. Remember that? Okay. And then, so X is the formal parameter. It corresponds to actual parameter A. Y is the formal parameter. It corresponds to actual parameter B. But now what does order do? It says, now if X is a pointer, then star X is what? That is the integer. It's the integer to which it points. So you see why that's if star X is greater than star Y? Yeah, so it's comparing integer values. It's not comparing addresses. Is everybody clear? In order.
If we hadn't included the asterisk.
It would actually be comparing the addresses, and who knows which one would be a bigger address. I mean, what's your address? What's his address? Which one's bigger? You know, I mean, you see what I mean? It'd be kind of nonsensical.
Yeah.
But it would compile. Yeah.
Over there, where they...
That is a very good question. So the observation is that order calls swap. Now tell me, what is X? It is a what? It is a pointer, which means that it's an address, right? Okay. So you see how that works. That's compatible. All right. So X is a pointer and Y is a pointer, and sure enough, in swap, R is the formal parameter that corresponds to the actual parameter X, and it is type compatible because it's a pointer to an int. Yeah.
But when you're doing scanf, you have to put in an and.
Ampersand. Yeah. Actually, you know, now we see that's the exact same principle, because scanf is using this mechanism, and that is the actual parameter. Do you see that that's compatible with what we're doing here?
Well,
Do you see? Okay, in the same way that order uses ampersand A because the purpose of order is to change the value of A, scanf uses ampersand because the purpose of the scan is to change the value of A, is to get the value from the input and change the value of A to that value. So we have to be passing the address of A in order for that to happen. Do you have a question?
Yeah, so for that if statement, is that saying what is that that address is greater than what is it?
No, 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 no.
Let's say the
Oh,
actual address.
No, 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 hold on. In void order, that if statement says if star x is greater than star y. So it's comparing the value, the integer value. It's not comparing addresses.
Yeah,
Because if,
what's at the address.
yes,
So-
it is the integer at the, yes, yes. But this is all compatible, this is all consistent.
Okay.
All right, so now the mystery is revealed of why we have to put the ampersand in the scanf, because the scanf is it's like order. It's like calling order. Calling scanf is like calling order. We want the value to change. We want the value to be changed. We want it to get the value from the input stream. And so its value will change from the input stream. Is everybody clear on this? Okay, so now here's how we illustrate this in the stack, in the runtime, on the runtime stack. So A and B are global, so here in figure 2.21 part A and B are global, so they are at a fixed location in memory, and they're, on the runtime stack we have the stack frame of the main program, and then we input A and B, so they get 2 and 6, and then what happens is we call order. Now how many, what, is order void or non-void? It's void, so what's the first thing? So we don't push storage for the return value. So what's the first thing? Parameters. And what are the parameters? Yeah, they are addresses or pointers. So notice that it's X and Y. Notice that we label the stack frame with the formal parameter name. So do you see that X refers to what? A, and Y refers to what? B. So do you see how that arrow works? And then we have the return address, and then there's no locals. And then what happens is order calls swap, right? So R, and notice, and what did we pass? We passed X. X got passed as R. So that means R is pointing to the same thing that what?
X.
That X is pointing to. So do you see how we notate that? So that's the stack frame for swap. So any questions about this? Okay. And then we return. Oh, and by the way, when we change S, really, what are we changing? If we say S gets temp, or temp gets S, or if we say S gets something, what is actually changing? B, because it refers to B. So see, A and B are 6 and 3, are 6 and 2, but then after we've done it, it's 2 and 6. A and B are 2 and 6, so they got swapped. And then when we return from order, then it's just the A and B have been changed because it was called by, in effect, called by reference, even though technically C does not have call by reference. But we achieved the same thing. And now, you guys, what kind of a function is this fact? It is, what does it call? Does it have a loop, does it have a for loop in it like the other one did? No. It is recursive, but it's the same thing. Same things get pushed onto the runtime stack. All right? So now what happens is, and won't go through these individually, but the main program, we start with the main program. The main program gets 4 into num. It calls, oh, and by the way, here's where we're going to start omitting the stack frame of the main program, all right, just for simplicity, okay, just to not clutter up the diagrams. Okay, but it's still on there, in real life. All right, so here we call fact, and so we have the ret val, n, and the return address, and notice that we have passed 4 to formal parameter n, so n has the value 4. But then with that if statement, we're not at the base case yet. So what does it do? Fact 4 calls what? Fact n minus 3. So it calls fact 3. So do you see that in part D of the figure? So now there's a return address and an n and a ret val, and then 3 calls 2, another stack frame, 2 calls 1, another stack frame, and finally we hit the what? What case? Finally we hit the base case. Okay. And so we can, and so now what gets returned? 1. So do you see then that in that ret val in part G of the figure, that ret val got the 1, and then what happens is when it returns, that 1 is used to, in the previous call. And so it takes that 1 times 2, and then see in part H of the figure that 2, 1 times 2 is 2, and then when that returns, that 2 gets multiplied by what?
3.
The 3, and then in part I of the figure, that's where the 6 comes from. And then, does everybody see how that works? And then 6 times 4 is 24, and then boom. So what got printed out is 24. Oh, and by the way, in this case, it returned where? Oh, here, let's look at the return address. What was the return address? Here in figure 2.22. Notice here that RA1 is what? Not after that statement, but it's part of that statement. And notice that RA2 is not after that statement, it's part of that statement, because it's non-void. So that's your point that you asked about earlier. And so here's the call tree. Goes down, comes back up. Fact 4, main calls fact 4, which calls fact 3, which calls fact 2, which calls fact 1, and then those values are the values that get returned. Okay? You can read about the figure 2.25. This is a global array, and so here's in figure 2.26. Here's how the array is laid out in memory: list sub 0, list sub 1, list sub 2, list sub 3, list sub 4. And then we have this phenomenon that all arrays in C are by default passed by what? By reference. So you don't have to put the ampersand. The ampersand is automatic when you pass an array. So that A is an array. And what does that array point to? What does that A point to? Which element of the array? The very first one. That's important point. Okay? And here is now this is the one that you have to do for tonight, right? The stack frame for the binomial coefficient. So figure 2.27 is I think you've done this before, right? I think we usually assign this in the intro class. So the binomial coefficient, so it's the binomial coefficient of nk is what? It's Pascal's triangle. Yeah, it's Pascal's triangle. So here, we can see from the code what it is in figure 2.28. If k equals 0 or n equals k, what do we return? 1. Otherwise, what do? We call n minus 1 k and n minus 1 k minus 1. And then we add them. And so what happens then, now let's see if we can count how many elements are on the stack frame of bin coefficient. Is it void or non-void?
It's non-void.
It's non-void. So what's the first thing? Ret val. What's the next thing? And the parameters. So that would be what? Ret val, then n, and then what? Then k, and then the what? Return address. So that's 4, and then what? Which are locals are which? Y1 and Y2. So there's 6 items on the runtime stack in that order.
Each time it's called. Right?
Each time it's called. Look at that sucker in figure 2.29. So look at it's ret val, nk, ret address, y1 and y2. And so BC31, 21, 11, return, then back up to 10, then return, then back up to 20, then return. Yeah.
On the homework,
Oh, now that's important. I'm glad you asked that. Look. There are 3 return addresses altogether. well, there's actually 4 counting the return address from the operating system, but there's 3 so there's a return address 1, and you got to make sure you get that right. There's a return address 1 here, and then there is a return address 2 here for Y1, and then there's a return address 3 here for Y2. Yeah, so you got to keep those. And if you notice if you go through the figures, you can see where, and it's easy to get that one wrong. Actually, that's a common mistake. So be aware of which one you're going back to, yeah. No. Oh, yeah, hold on. Yes. Return address 1 is the address of the printf in the main program. Are you with me? Return address 2 is the Y1 assignment statement. Return address 3 is the Y2. Yeah, are we good? Yeah. All right, good deal. See you next time.
Can I ask a question on the